Good evening. I'm Spruha Satawalekar. I am a PMRF TA and I'll be taking you through assignments of week 3 NPTEL course of User-Centric Computing for Human Computer Interaction today. We'll be doing some problem solving. We'll look at the assignment questions that were asked last year, and so that you are prepared for your exam as well as prepared for solving some of the questions in this assignment as well. So what happens when in a usual NPTEL exam is you get very rare opportunities to interact with the course instructors, get your doubts solved. So for that purpose, PMRF scheme has started this, given us an opportunity to interact with you and solve your doubts if you have any, and also help you make the assignments, because NPTEL assignments consume us 25% of your overall score of the course, and the examination score will be graded as 75% of your overall score. So that's why these assignments are very important. And if you solve the assignments weekly, it kind of doesn't keep the burden of studying the entire thing and on the in the last moment during the exam. So welcome. I'll start. This is a kind of interactive session, so if you feel free to unmute or write in the chat box. There are some activity questions, assignment questions, so you can give your answers as well. So we'll begin. So let's take a recap of last week. We started with the software development life cycle for user-centric computing, and we saw that requirement gathering or contextual inquiry is a very important phase in which you get to know the users. So we saw the types of contextual inquiry, what are the means to do them, how to what are the stages of contextual inquiry, that also we learned. Then we went to the design phase. After requirements are gathered, we go towards designing, and in designing we studied the 8 golden rules of by Schneiderman of design. And based on those design guidelines, if we can design a particular system or a software, we might be able to get the user centricity incorporated within it, with at the design stage itself. However, still, even though we are incorporating user-centric design principles in the design stage, we have to make a prototype and then get the prototype evaluated iteratively with the users. So there we studied a design, a prototype, and evaluation cycle. So once that is done, now we know what is the prototype that works well for the users. We saw the types of prototypes that can be created and user feedback can be received. Then comes the stage of user-centric computing, that is the next stage of software development, in which this prototype or this user behavior itself informs the model. So we'll talk about software, how the layers of software are, and what user-centric computing does to these layers. So there are three layers in the layered view of software. In the top level, there is application software layer. So take example of any software that you use, any application that you use on your phone or in your physical environment. Think about the application software layer as the interface through which we interact with the product, and the software that controls that product. Then below that layer comes the operating system layer and the hardware layers. So these are fundamentally the layers which might be describing the platform on which the application runs, or this might be the system on which the application is going to run. Of course, that compatibility is also an important thing, but today, here onwards, we are going to talk more about in depth about application software layer. So let's explore what is in this application software layer. So this application software layer is basically divided into two sub layers. So this sub layer 1 and this is a sub layer 2. So in the sub layer 2, it's pretty simplistic design, right? So here interface threat predictor is there. Basically the software that actually modifies the input and output, modifies the input to generate the output. You can make it in a, or if I try to oversimplify it, it resides in that second sublayer of the application software layer. So what happens in the sub layer 1, user can provide input to the to this layer through input provider layer. So this input provider stores the user's input, and it provides this data to the interface state predictor. Then there is a collector box. So this collector block is actually creating the and storing the initial state or the current state of the machine or of the software. So this collector holds responsibility of telling you what is the status right now of a particular variable or a particular action. So that is the current state. So the current state and the user's input to manipulate that state go into the interface state predictor. What is this interface state predictor? It is the actual software which manipulates these two to form the new state. So what is the state of? It is the state of the interface. So I will explain with an example. So when I enter a kind of a software that enables me to shop, suppose say Myntra or Nika or any other software, or a book software, book purchasing software. When I first enter the software interface, there will be some state that is stored of the existing layout or the interface that is stored in the collector. When I explain to the interface through my actions what is it that I like and what is it that I want in my cart, it is the action that is adding the input to our application layer. Now once I've added this selections from my side, I've given some input. What happens is, there are two things that the interface state predictor combines. It combines my input and changes the state of this interface, existing state of this interface, because now the interface state predictor has to show me, right, that this item has been selected, has been moved somewhere. So I should see that on the interface. So that work, what changes need to be done, that work is done by this interface state predictor. It sends the state to the renderer. So the renderer takes care of showing those states on my screen. So that is the new state is sent to the renderer, and it gets shown on the application software layer through the renderer block. Now we see that the layers need to be revised, because over here there is nothing about the user, right? User centricity. So user is only giving the input to the system. So now we bring in the user in the picture. So this is the user state predictor machine that goes into the sub layer 2. So there is another layer introduced. What does this user state predictor do is, it will keep on receiving this input provided by the user, and it will model the user's behavior of sharing the input. So this model of the user is created within the user state predictor, and that model is provided to the interface state predictor. That model takes care of manipulating the current state of the system and gives inputs to the interface state predictor, which then tells the new state to the renderer, and renderer does the work of showing it on the application software layer. So this user state predictor, if you replace the user state predictor, what would this software do? It will always take the input, it will always process it the same way, and it will always show it in the same way. Whereas if the user state predictor is present, there is an opportunity to make adjustments in the layout, make adjustments to the way the viewer sees the layout, so that it is easier for the user to learn this software and grasp it and get happy after get the satisfaction of using the interface. So that is about the revised layers of application software. Now we talk more in detail about the user state predictor layer, sublayer. So user state, what is the user state? It is a performance measure. It is a set of mental variables, or you can say it comes out of the mental variables, gets measured. So for example, uh, task completion rate. A user takes up this much time to complete so many tasks. So the task completion rate is the user's capability of finishing up a task with finishing up a task. Then there is error rate, that is how many times a user will be susceptible to creating an error in the interface while working in the interface. Then there is cognitive load, which is about the load that there's so much information sometimes on the screen that a user might get overwhelmed with the information. So this sense of overwhelming or being okay with the information that I see on the screen, that is kind of known in a simplified terms. That is the way I would describe cognitive load. So it's, remember, these are really simplified definitions. These are not definitions at all. These are kind of simplification for your convenience to understand these terminologies in a very simplistic manner. Now talking about this user state machine again, this does not directly inputs or takes the inputs or user parameter. It can be captured by monitoring the user processes. So user state is not given by any internal any user state with respect to this task completion or error rate. These are not directly entered by anybody. We don't need to enter these, but they can be captured by monitoring these processes in which users interact within the system. And we compute these values to represent the cognitive state of the user, the mental state of the user at that instant. So that is, after computing that, what we get is the performance measure. So the goal is to definitely improve this performance measure and to improve the user satisfaction. So we want to predict the next interface state which is very desirable for the user using this performance measure and the user satisfaction. Why? Because if you can recall, earlier we had systems desirable components for a system, for a user, for a better usability of a system. So these were learnability, efficiency. Learnability means any new person or an expert can learn this application very fast. It doesn't take too long to learn it. Then efficiency is the time in which the user can complete a task. Memorability is recalling what we did last time when you are using the application next time. Low error is the desirable system. Actually, the terminology is error, but here I'm expressing in low error because the sentences system should have low error. So the error proneness of the system should be lower, and the satisfaction that the user gets out of interacting with your system or your software should be high. So these are all the ways in which to achieve that. These are all the goals. To achieve these goals, we have performance measure, and by improving this performance measure, we improve the user satisfaction. To do that, we need to create the next desirable step or state for the user. So that is the basic idea of what we are doing within this user predicting state predictor. So user state predictor, we want to predict the next interface state which will be desirable for the user. So initially it was not necessarily desirable for the user. Here this keyword is desirable. Now, types of user-centric software are there. One of them is adaptive and non-adaptive. Adaptive interfaces are the ones where interface layout changes according to the user action. So input provider is required to take the user input, because the how the user interacts with the system, it will change the look and feel of the entire interface. Whereas non-adaptive user-centric softwares, these are also user-centric. Okay, it doesn't mean that they are not centered towards user. So these are basically designed through a static interface design point of view. It need not adapt with the way user interacts with the software every time. So input provider is not required, as the design does not change depending upon the user input. So maybe this slide will be useful for your exam, or there are some questions in this assignment for depending upon this slide. So next is the given an example of virtual keyboard case study. So I would request you to go through the video and check out the how the virtual keyboard can be designed, and what are the ways in which the non-adaptive software can be, and adaptive software can be helpful in optimizing this desirability of virtual keyboard. So the goals for this desirable state were, initially we learned these maximum learnability, satisfaction, error, low error. Now here, in terms of interaction with this context of virtual keyboard, what the user tries to do is they try to enter a text, they try to avoid errors, and they want to finish up faster typing fast. So they should not end up spending a lot of time finding out where is this key, where is that key. So this is the main crux of desirable state for virtual keyboard, that you maximize the text entry rate, then minimize the error rate for the users, and minimize the key search time. So key search as in where is the key, that time. What would a computational model contain in order to achieve these goals? So the computational model contains user behavior of the way of the user the way in which the user types, the way in which user makes mistakes, how often do they make mistake, what is the within a 1 hour period, how many mistakes has the user made while typing. That is the that will give you the error rate. And then we also measure the weight. We also try to map the user behavior of searching objects on the screen. So if the user prefers to search for the keyboard at the bottom, there is no point keeping the virtual keyboard at the top of the page, right? So that is kind of the mapping of user behavior in order to achieve these desirable state goals. Can you guess which layer of compute of this application layer computes this performance measure? So we have already talked a little bit about it. So now I think we will guess about it. So the actual layer that talks about this is the user state predictor layer. So the next layer, that is the interface state predictor, what does that do? It generates specification for the interface. It decides the relative position of the interface elements, for example the color, fonts, font styles, font sizes, the text sizes, and then the design is updated once the user state predictor gives input to the interface state predictor. We update these layout elements, and then we show the application layer to the user through renderer. Okay, so there's one more takeaway from this VKB study. If in case the VKB or the virtual keyboard is an adaptive software, so what happens is, initially it was a non-adaptive software, so depending upon the user's actions, it won't go on changing. But here in the adaptive software, we see a lot of suggestions, adaptive word suggestions, and then autocorrect, and then user input gets used to rearrange the keys and layout of the system, so that you can predict the words that user types a lot, and then suggest them the same wording. So that is the way in which adaptive software or the adaptive computational models work. Okay. Now this is an old assignment question. Is it possible to define user state as a set of performance measure? So the question is it possible to define user state as the performance measure? And the answer is yes. So performance measure is nothing but the variables, mental variables that constitute a user state. For example, the uh, error rate, the task completion rate, or cognitive load. We have seen this previously. Okay. Another old assignment question. The interface state predictor takes the predicted layout as input, specifies the entire interface, and invokes dash to display on screen. So what does interface state predictor take? It takes in the predicted layout as input from the user state machine, specifies the entire interface, mentions the color, font, and placement, position of the elements, the sizes of the elements, and then it invokes the something to display on the screen, and that something is a renderer. Alright, remember the third block on the sublayer 1. Okay, so now the question is, what is a model? So model or user state predictor which works with a model. So what is that model? It is the behavior of an interactive system. So interactive system as in, we take into account not only the computer aspect of it and not only the human aspect of it individually, but we also consider them together. So what it means is, you have to look at the interactions of humans, and that means the users, with the computer for coming up with the user state predictor model. What are the benefits of coming up with a user state predictor model? User-centric design model can be created, and it helps in formulation of design guidelines. So if you have a few design guidelines based on the user-centric approach, what you can do is you will be having some form of user satisfaction even in the initial design, right? So even in your initial design, by following the guidelines, you can have a better, very good quality of prototype. And there's also the issue of standardization. So when there are multiple people developing the same software, formulation of design guidelines always helps them. So that is another benefit. Then you can integrate a computational user model into the system itself. So you don't need to always compute it on your own. You can integrate that into your system because it is computational. So computational means you can create a software to do the same set of instructions, right? So that can be done, and then it kind of gets to a point of automation. And you can also create guidelines or heuristics to evaluate it. So recall the diagram that we saw of software development life cycle. Okay, so there was this block of design, prototype, and then evaluate. So we have to evaluate this prototype also iteratively, and that can be a taxing process. With this user centric models, we will be able to create a very good framework or heuristics or checklist for an evaluation of the design, and we can automate this evaluation process. Similar to the design process, we can also automate this evaluation process. All right, so in between, if you have some questions, let me know. You can comment on the video so that I will look at the comments afterwards, and I will respond to them. Okay, now let's talk about user-centric models, types of them. So there are descriptive models and there are predictive or performance models. So predictive models are also known as engineering predictive models or performance models. This is just nomenclature, different nomenclature. In the descriptive models, we have explanatory description of user behavior in specific context. So it does not predict anything for the user, what the user will do next, that is not given. But how the user usually performs within the specific context of this instance, or of this, that is matching to this instance, that can be captured through descriptive models. Whereas predictive performance models, they can predict the state of user mathematically, and they can compute the state variables, so that prediction of the next state, the desirable state, can be obtained. So there's this as old assignment question, last year's assignment question. Descriptive models are also termed as performance models. Is that true? What is the guess? Okay, so it is false. The predictive models are also termed as performance models. It's kind of really recall level question. In the model taxonomy, the user-centric models are characterized as we saw, there is descriptive and predictive, definitive and predictive, descriptive, productive, or none of the above. And the answer is descriptive and predictive. So these descriptive models will give the elaboration of the user behavior, and predictive will give a prediction of the user behavior. Now let's look at the types of descriptive models. So there are three types. First one is the Buxton's three-state model for graphical input device. It was created by William Buxton in 1990. What this model captures is a graphical input to modify the states. So this captures the behavior of users of pointing devices, only of the pointing devices. So that is the keyword of this Buxton's model. So it cannot be used for any other state machine, any other state machine for any other use. So it is only for modeling the behavior of users while using pointing devices such as stylus, multi-button inputs, touchpad, mouse, all those things, right? So whenever they are using some pointer-based device, for those Buxton's three-state model is useful. In the I think let's first go to this model then. So here is an activity. It's kind of an interesting activity, but since we don't have any live users, we can do this offline. You can go to the lecture 11 video from the course and watch this time frame. What the video explains is a state machine, and what it does is it shows us how in state 0, in state 1, and in state 2, the the person who is using a mouse pointer, how they interact with the system, what are the possibilities of user interacting with the system or with this mouse pointer, and how to address those actions, or the user's actions. So that is very well described. I had formed a question about it, that what category does Buxton's three-state model or graphical input devices fall under. So is it a descriptive model, or is it a predictive model, or both? So of course the answer is descriptive models. So Buxton's models we have done. Now let's go to the Giard's model of bimanual skills. So it was developed by Giard in 1987. It represents our hand movement behavior while interacting with the object. So initially Buxton's was the three-state model for pointing input devices, and here it is for hand movement while interacting with a graphical user interface, maybe, or any other software. So so here's the question for that previous one. We'll skip it now. So Giard's model that talks about bimanual control or laterality. So we can always observe that we don't use our cell phones or our computers or our laptops with only single hand. That is a preferred hand. Or say you are a righty person, you're a lefty person, you will have a preferred hand and then you will have a non-preferred hand. So we usually see that we use both the hands while performing tasks. So intuitively what we think is there's only use of one hand, but actually there are two. So if we read the paragraph, it is actually the task of non-preferred hand to lead the preferred hand. So non-preferred hand is also doing something cognitive, some cognitive action, which is very much useful for the preferred hand. And it is kind of a guiding towards the for the preferred hand. It sets the spatial frame of reference for the preferred hand. In other words, it sets a region in which preferred hand is likely to move around, and it performs some infrequent and small movements within those. So the non-preferred hand has infrequent moves, small movements, whereas the frequent hand has lots of movements. When it comes to preferred hand, this preferred hand follows the non-preferred hand and works within the reference frame set by the non-preferred hand and performs finer movements. So that's why we get this intuitively. We feel that the preferred hand is acting more, but it doesn't. It is not so. Non-preferred hand also has works towards creating a spatial frame towards it. So now we have this question: in which of the following examples would you use Giard's model? Consider Giard's model. So there's stylus, there's desktop screen, there's keyboard, and then mouse. Which one is best suited for to adopt Giard's model? So I'll give you the answer now. Stylus and mouse are both pointer devices. User performs pointing actions through this. So these are both we can you prefer to use Bookchan's model for this. Whereas the desktop screen is kind of a GUI. So for a GUI we don't know which one to use. So right now we don't know. So that's why we will choose keyboard. So keyboard is the correct answer. Now we talk about the desktop interaction. So we talk about the GUI. So there's Norman's model of interaction. So Don Norman gave this model of interaction. Okay, Norman's model of interaction was developed by Donald Norman in 1988. A relatively detailed model of mental and sensory motor activities is is developed by Don Norman. So we'll talk about how these mental, sensory, motor activities are incorporated within this model. So I think this is kind of a segue into our gulf of execution and evaluation. So it is known by different names. Sometimes it's known as gulf of execution evaluation. This is execution evaluation action cycles, or this is also known as 7 stages of action, or Norman's model of interaction. So there are different names to this same model. So the first 3 stages, so let me take you through these stages so that it's easier to understand. When I enter, so you view this from this top, okay, as a user. So when I enter a system or I want to perform some action with a application, I have certain goals with me. So I want to perform a certain action. Say for example, I want to open my phone, I want to send a message to my friend. So that is my goal. Open my phone and send a message to my friend. So I have the intention to act. So I form this mental intention that I will open this phone, I will go to messages, and I want to type a message. So I have some message intention to perform. So that is the kind of mental element into the first stage, the intention to act. Then after I have this intention that I want to message my friend, I will go to the sequence of actions. Earlier, I think I by mistake told some of the sequence of actions. So I think initially there is only the intention, and then the sequence of action begins. So when I want to send my message to a friend, I think about this sequences of actions that I have to perform. So since I am an expert user of a phone, I know that I have to first open the lock screen, then I want to search the message button, then I want to open this message button, then I want to when click on it, then I have to find my friend's number and then contact number, and then I want to type the text. All these steps are determined now in my mind, because it is, we have been using mobile phones so frequently that sometimes this sequence of actions formulating this sequence of action is very easy for us. So that's the ease that we are talking about. Okay. So user is thinking about the sequence of actions. After performing these actions, after thinking about these actions or planning these actions, then the user performs. So this action performing execution is known as this execution of the sequence of actions. So these states of from the having some goals and intentions and performing a sequence of actions, all these stages are called as a gulf of execution, known as execution part of the Norman's model. Execution as in what I'm going to perform with the application, or as a user what I'm going to perform with the application. Now, note that these three stages of forming goals, intention to act, and then thinking about the sequence of action, these are three mental and cognitive stages, elements. Then comes the uh, in the system, we interact with the system by performing these tasks, and then comes the next stage, that is perceiving the state of the screen or the system. So here, instead of the word world, think about the word system or application. Okay. So now once I have performed the actions that I wanted to do, I can see the system, I can view the system. So that is kind of a sensory state. Oh, I forgot to say that performing these actions was a motor state. Now this perceiving this, what changes in my screen, that is a sensory state. So not necessary that there will be um, something that will pop up on the screen always to view by the eye. There might be some haptic feedback, or there might be some kind of voice, or a ting kind of signal that they have when the message is sent, or when a message is delivered. So that can be sensory in terms of different senses of a human being. So this fifth state is for sensory. And then there is, once I receive this sensory ting, or a kind of change in the layout that is visible, I will have go through the interpretation of what I perceived. So as a user will go through the interpretation of that, yeah, delivery has happened. And if in case instead of ting, it gave some different noise like "ning, ning, ning, ning," so then I will find out, oh, it didn't go, what happened. So that is the interpretation of perception, that something went right or something did not go right. And then I think about the evaluation of this interpretation. So evaluation is whether it was performed well, rightly, or it was not performed rightly. So all these two stages are a part of mental cognitive stages, the interpretation and the evaluation. So that kind of takes care of the evaluation part of this Norman's model of interaction. So, to have the user happy with our software, to create a user-centric software, we need to balance the gulf of execution and evaluation. We need to make the user goals satisfied once they evaluate the interpretation. Okay, I should get this satisfaction that message was sent, or I should get this satisfaction that, oh, the message was not sent, so I need to edit something, I need to change something. So that information needs to come to me. Okay, so that is the Norman's model of interaction. So based on this, we have some questions. Norman's model of interaction consists of dash stage of action. If you don't count the world or the system stage, because it's not a stage, it's kind of what you are interacting with, then there are 7 stages. Norman's model of interaction has broadly 2 stages of interaction: execution stage and dash stage. So we saw that it is the evaluation stage. Okay. Next, we go to the predictive attention model. So initially, we have been talking about descriptive models. In descriptive models, there are 3 types of models that we saw. One was Houston's three-state model. In the second one was the Giard's bimanual lateral model, and in the third one we saw the Norman's interaction model. And now we will go towards the so the descriptive models are now over. Remember, descriptive models will not give you the kind of prediction of what the user is going to do next and how to help them solve this next, based on the user interaction in the real time. So that is the difference. Next we go to predictive attention model. In so this is a type of example of predictive attention model given. So it is a PAM attention factor. So predictive attention model. What is the attention factor? That if you see a lot of data on the screen, how will you identify which element the user will always focus on? So traditionally they have observed that 10 seconds is the maximum time for which the user stays on a screen, and then they scroll or they exit the screen. So how to optimize the user's experience while viewing the screen for 10 seconds? So that is the concern. So this equation over here, attention factor, for attention factor, it's not like A B C is not defined here. Every time the model is generated, and A B C can be defined, can be identified. So how this prediction is done? The user behavior is observed, and data is collected multiple times, large number of times, and out of those large number of collected data, your behavior is analyzed and modeled using a predictive attention model, in which, mm, in terms of this screen viewing thing, attention factor, it is calculated for the ith element. If I'm focusing on element I on the screen, it is attention factor of I is equal to the A into the position of I plus B into the size of I plus C into the contrast that the eye has. So there may be other factors also, like color, and then what is the font, or the timing at which it is popping up on the screen. So all those factors will also come into picture. But these are the kind of basic example of attention factor. So what we want to do is optimize this attention factor, so that what the information that we want the user to look at, it gets highlighted for the user. So the user doesn't have to look at the screen and then keep searching for where is the information that I was trying to find, and how time consuming is this interface. I'm really tired now. Where is this? I can't find it. So this is one aspect of being unable to find something on the screen. Then there is a lot of information on the screen, and I'm not able to digest it. I get some cognitive load. So to solve these issues for the learner, and also to while presenting information, we also want the user to read the information. So that is the purpose of the designer. So to make the user pay attention to where we desire for the user to pay attention at, or what is desirable for the user. Rather, I would phrase it like that. It's not about what the designer wants the user to see, but what the user wants to see first. So that is the attention factor. If we know about it, we can place this ith element at a optimum position, at an optimum size and an optimum contrast, given by this A, B, C values, and that becomes the model for predictive attention. Okay. Mm, so that's kind of an example of predictive attention model. It's been really well described in the video. Why to use this predictive models? So it is essentially, it tells us that relative importance. So I have by mistake written PEM, or you can write it predictive engineering models as well. So it's not actually not a mistake. So it essentially tells us that the relative importance of the ith element on the screen in drawing the attention of the user with respect to the other elements present on the screen. It tells us about the likelihood that the element drawing will draw your attention before the other elements that are having less attention factor will be seen. So that is the key. So even if to share a very oversimplified example which is non-computational in nature, if you view at this slide, there is very less chances that you are going to read all this, but you might be able to read the highlighted, the contrast one, higher contrast one, this the last line of predictive models that are used in computing behavior, which helps in taking more refined decisions at many stages of the design. So what I have done here is I have highlighted the things that I want to read, want you to read. So there is a contrast element that I have used over here for you to gain your attention, right? So this is a non-computational way, but there is a way in computation in which I can determine where the users finally actually look at the most, and then place my important information at that local locations, at that positions, in that color, in that contrast, and um, with that font size. No? So I'm gonna take a minute of break. So now I'll explain how is that it is predictive. Why is it not descriptive? That if I know that users usually read an information on a screen in an F pattern. Okay, so I will draw this F, and what users usually do is first they traverse this first line of the user of the screen, start from left top of the screen, they go towards the right top of the screen, and if there is nothing that of that interest, there is chances that they might first scroll through the screen in a vertical direction, even at the left hand side, and then they will look at the middle portion of the screen. So that's why it is a F pattern that we follow, not like F pattern like this, F pattern like this that we follow while watching a screen. So that becomes the descriptive model for me, right? So I can use this description and I'll arrange something like that. But how does predictive model help me is that right now the user is viewing like this. What will be the next possible element that the learner user will focus on in the screen? So once I know that, I can place my most important information that I want the user to capture at that particular location. So that is the purpose of this. So to give you an insight into how this is part of our lives without even knowing, we usually even let's take that same shopping example. So we add things in our cart, and then there is this message that appears: users who have bought this have also bought this. So so there is a location where to post this message that is also identified. We are now predicting where we would look next. We are most likely to pay attention on the screen. So these algorithms that we say are there, which are for user centricity, which help us to save our time and then save our effort and these are existing within our own knowledge area or our world, that we, I mean, in our day-to-day life rather, right? So having talked about this use of predictive engineering models, and how they are helpful for us as designers as well as users, let's go ahead to the questions. What is the full form of PAM? So it is predictive action model. Sorry, predictive attention model. We saw the attention factor example. Uh, Next is the three category of computational models. So in the video lecture, we see that there are context specific behavioral models, then there are simple models of human information processing, and then there are formal models of interactive systems. So if you look at the complexity, context specific behavioral models are a little bit less complex. Simple models of human information processing are a bit more complex than the context specific ones. And then this formal models of interactive systems are even more complex. So what are these computational models exactly? We saw the one example of PAM in the previous slides. Now, in this week, we will not go into the depth of computational models, but we will see one of the examples, that is goals, operators, methods, and selection rules. So, there's a question about this in the assignment, this current assignment as well of NPTEL course. The goals, operators, methods, and selection rules was created by Card, Moran, and Newell. The Psychology of Human-Computer Interaction was their seminal book, which came in 1983, in which they explain the goals, operators, methods, and selection rules. Set of rules for designing predictive computational models. So some of the examples or the categories of these models are, first is the KLM goals. It is about keystroke level model. The keystrokes while performing computational actions with the computer systems or with the softwares. Then there is CMN GOMS. So can you guess what is the meaning of CMN? You can look at the slide and you might be able to find out what it is. There is CMN somewhere, which is very easy to identify. That's right. It's Card, Moran, and Newell, CMN. So this was an original model of given by Card, Moran, and Card, Moran, and Newell, about GOMS. Next is the NGOMSL. So this is about natural geoms language, natural model of this goals, operators, methods, and selection, uh, and integrates language for it within it. Then there is CPM GOMS. It is about cognitive perceptual model. So these are two different ways in which the acronym is formed. Either you can say cognitive, that is mental things, perceptual, that is what you perceive, and motor, that is what you perform actions with, movement related. So cognitive perceptual motor, or the critical path method, that is also the CPM acronym. So these are the some of the questions in assignment are about this. Now let me take a moment to explain why should you attend these lectures. Okay, so one of the reasons is you get some time to attend a session, and we can keep it short. If you don't want to sit for 2 hours, we can keep things short, and we will get us a revision of uh, this weekly material, so that we don't have don't spend a lot of time in the last moment rush. So we don't want to have a last moment working on entire syllabus. So if you attend and then again there is a chance of interacting. So if you have some questions, even if you don't have questions, mm, what we do during this problem solving session is we go through the content, and while going through the content we also simplify it for you. So that's why I think, instead of skipping the session, you should attend it. If it attending is not possible, please do watch it on YouTube channel, and you can um, subscribe, and so that whenever next time I upload the next video, you will be notified about it. I'm looking at the comments in the first previous 2 weeks, and I'm so glad that there is a response to what we are doing. And we were told that we should take up these lectures in English. So last 2 weeks we had more population who were speaking Hindi, so they preferred Hindi. So I explained a lot of examples in Hindi and just gave the information in English. So today I have addressed that feedback, and I have kept the entire session in English. So I hope you will like it, and please share it also. Thank you.